Dear students, in this lecture, we are going to study the basics of logarithm. So this is a very scoring topic, but provided you are thorough with the rules, because this chapter is not about formulas, learning formulas. It is more about learning the rules and how to apply those rules. So unless you are familiar with those rules or the basic rules of logarithm, so you will not be able to solve many questions that are framed from this topic. So the first and foremost thing that we need to do is that we need to master, or we need to understand all those rules that one needs to be knowing before one gets down to the solving the questions. So let's see what are the basic rules of logarithm. So the first and foremost rule is the rule of multiplication. So what does this rule tells us? It tells us that log a into b can be written as log a plus log b. So let's take an example to highlight this. So let's suppose you have a number log to the base 10 of, let's suppose, 45. So if you realize that 45 is actually 9 into 5, so it is like log of a into b. So this can be written as log of a plus log of b. So this is known as rule of product. So similarly, rule of division, instead of multiplying two numbers, here we are dividing one number with the other, x upon y. So in this case, the rule tells us that log a by b is equal to log a minus log b. Okay. Similarly, had this been log 10 to the base, let's suppose it would have been 5. So this 5 could have been written as log 30 by 6. In this case, it could have been rewritten as log 30 minus log 6. So these are the two basic most rules, rule of multiplication and then rule of division. Now let's see the rule of exponent. So this rule, third rule. So what does this rule imply? So if log 2 to the base, let's suppose 5 to the power 7. So this exponent can be taken outside and multiplied. So this can be written as 7 into log 2 of 5. Okay, so this is the rule of exponent. So this is the rule of surds, this rule. So what does this mean? This means that if you are taking any root, nth root, then how that is to be dealt. So had this been nth root, 7th root, so this would have meant 5 to the power 1 by 7, and then you could have treated it just like you would have treated the exponent 1 upon 7. So these are basic rules. Okay. So what about this rule? What is this rule trying to convey? It is simply trying to say that 4 log 3 can be written as log of 3 to the power 4. That means a number, when taken from multiplication to inside of the logarithm, it acts as the exponent. Okay, and this is the most commonly used rule. So this you need to understand. This you might be, for some of you might be coming across for the first time. So log 5 to the base 3 can be written as log 5 by log 3. Now some of you would say that what is the base of these two numbers? Any number. For both the bases, it has to, if you keep common, this ratio holds. Now let us put these rules into practice to understand what you just saw. First and foremost thing, what is meant by log? What is meant by basic log? Suppose it is given that log a to the base 2 is equal to 3. This basically means that 2 when raised to power 3 becomes equal to a, or else a is equal to 8. So let's apply other rules as well. So suppose log 32 to the power 1024. So how to deal with this? if you ever get these kind of situations, if you observe 32 and 1024 both are powers of 2. So how can this be written? This can be written as 32 can be written as 2 to the power 5, 1024 can be written as 2 to the power 10. So now you have exponent both in the number as well as the base. So you can apply both in single step. So if you take out this exponent, it comes out and gets multiplied. If you take this exponent, this comes out and becomes the reciprocal. So log 2 by 2 is equal to 1, so becomes equal to 2. So remember all these small facts. Log a to the base a will always be equal to 1. And one more thing, log 1 to the base a, any base, is always equal to 0. Why? Because be any base, a to the power what can be equal to 1? The only possibility is a to the power 0. So these are the basic fundas that you must understand, you must realize. Let's clear a few more things. Suppose you get a situation in which you have something like this, log 500 to the base 100. Then you can write it like log 500 upon log 100. So if no base is given, it is always advisable to take the base as 10. By default, it means base 10. If no base is mentioned, suppose nothing is mentioned in your competitive exams, it is simply written log 20. So it means that by default, the base is 10, not even natural log. Please do not fall for this trap. By default, this is not natural. In competitive exams, it is always by default the base is given to be 10. Okay. So now let's try to solve a few questions so that you know you are clear with the concepts. So now let's get down to solving some questions. So here is the first question before us. So all these questions would involve application of the rules that we have just seen, we have just studied. So first question, it is like log a plus log b. So it is product rule. So log a by b plus log b by a can be written as log of a by b into b by a is equal to log of 1, log of 1. So it means that what is given to us? It is given to us that log of 1 is equal to log of a plus b. So from here it becomes very evident that a plus b is equal to 1. Now let's move to this one. What is the value of this expression? So we will solve each term one by one. So the expression is, the given expression is 1 by 3 log 125 to the base 10 minus 2 log 4 to the base 10 plus log 32 to the base 10. Now observe carefully that base for all the three is same, 10. So it is convenient. So what to do with 1 by 3? This 1 by 3 will go inside and take the form of exponent. So this can be written as log 125 raised to power 1 by 3 minus log 4 to the base 10 square. So this goes and takes the form of exponent. This can be written as log 10. Leave it as it is for now. So this is log to the base 10 of 125. Cube root of 125 is 5 minus log to the base 10 of 16 plus log to the base 10 of 32. So you can apply the product and division rule at the same time because it involves plus and minus both. So this can be written as base, you can keep as common 10. So 5 divided by 16. Why divided? Because here it is minus. So divided by 16 into 32. Why into? Because here it is plus. So this comes out to be log 10 to the base 10. So which means answer is 1. Now this one, as I already told you that log b to the base a is equal to c simply indicate that a to the power c must be equal to b. So we'll apply the same rule here. So 10,000 raised to power minus 1 by 4 is equal to x. This is what we are supposed to calculate. We are supposed to calculate the value of x. So let's do that. So x is equal to, now what is 10,000? It is 10 to the power 4. So 10 to the power 4 into minus 1 by 4. So this is actually equal to 10 to the power minus 1, which is in fact equal to 1 upon 10. Now the value of log 32 to the base root 2 is equal to how much? So let's see. So let this be equal to x. So it simply means root 2 to the power x is equal to 32. So from here you can say that 2 to the power half whole to the power x is equal to 32 can be written as 2 to the power 5. So from here you can see that x by 2 is equal to 5, which means that x must be equal to 10. The value of this expression. So let's see. Let's solve it from right to left this way. So let's see. The expression is something like this. All these are base. This 2, 3, 3 that you see before you, these are base. 27 cube. Now you'll have to solve term by term starting from right hand side. So first let's try to solve this bracket. Let's resolve this. Only this term we are talking about, how to resolve this. So this term can be written as 3 log to the base 3 of 27 can be written as 3 cube. Okay. So this 3 can again be taken outside. So this will become 9 times of log 3 to the base 3. So this entire term comes out to be equal to 9. This term, only this term, because 27 to the power 3 can be written as 3 to the power 9. So 9 comes out. So this term is 9. So log 2 log 2 log 9 to the base 3. Now let's concentrate on this term. So what is log 9 to the base 3? So this is 2, because 9 is 3 square. So 9 can be written as 3 square. 2 will come out. So this term is 2. So now the expression becomes this. So now what is this expression? This is equal to 1. So this now becomes log 1 to the base 2. So which is equal to 0, because 2 to the power x is equal to 1. It indicates that x has to be equal to 0. So the answer is 0. Now this is a good one. If log 7 to the base 10 is equal to a, then what is this expression in terms of a? So let us see. Log 1 by 70 can be written as 70 to the power minus 1. So this minus can be taken outside. So this becomes minus 1 into log to the base 10 of 7 into 10. So this can be written as minus 1 into log 7 to the base 10 plus log 10 to the base 10. Why? Because we are applying the law of product here. Log A into B can be expanded as log A plus log B. That's what we are doing here. So this is minus 1 of A plus 1. Because log 10 to the base 10 will be equal to 1. And log 7 to the base 10 is already given to us as equal to A. So the final answer is minus 1 to the power 1 plus A. Okay, now let's move to next one. So if log x to the base 4 plus log x to the base 2 is given to us as equal to 12, then we have to find the value of x. So how to solve this? So if you have observed, the bases are different. So that's the problem, that base came out to be different. But still, how to solve this? Let's see. So this expression can be written as 4 can be written as 2 square, and leave this as it is. So now what to do with the, because this time the exponent is associated with the base, so it comes out in the reciprocal form. So this is given as 2 as 12. So now we can rewrite this as half. This power I am taking outside comes in reciprocal format. Log x to the base 2 plus log x to the base 2 is equal to 12. So from here it is very clear that log x to the base 2 is equal to 24. Okay, this is a very good one. Let's see how to solve this. So it is given that log 4 can be written as 2 square, and this you can write it as it is. So this is what is given to us. So now this 2 square, if you take this exponent out, it comes in the reciprocal format. So it means that half into log x to the base 2 plus log x to the base 2 is given to us as equal to 12. So let's see what can we do with this. So if you take log x to the base 2 as common, so this comes out to be 1.5. So this is given to us as 12. So from here, log x to the base 2 is equal to 12 divided by 1.5. So 12 by 3 into 2. So equal to 8. So from here it is very clear that log x to the base 2 is equal to 8, which indicates that x is equal to 2 to the power 8. So 2 to the power 8 is equal to 256. So now let's move further. So how can you solve this? So you can solve this in this way. Log a to the base b can be written as log a upon log b, any common base. So we'll apply the same funda here. So the terms can be written as 1 divided by log 60 by log 3 plus 1 divided by log 60 divided by log 4 plus 1 whole divided by log 60 divided by log 5. So this can be rewritten as log 3 by log 60 plus log 4 by log 60 plus log 5 by log 60. So if you take log 60 common, so it will be log 3 plus log 4 plus log 5. So this is equal to log of, now you apply the product rule, log a plus log b plus log c can be written as log a into b into c divided by log 60. So this comes out to be 3 into 4 20. So 3 into 4, 12. 12 5s are 60. So log 60 divided by log 60. Answer is 1. Now, these three log terms are said to be in arithmetic progression, and based on that we have to find the value of x. So if three terms a, b and c are in arithmetic progression, then what is meant by this? It is meant that the average of first and third term is equal to the mid term. So this is what is meant when three numbers are given in arithmetic progression. This is what you are supposed to make use of, this fact that the sum of or the average of first and third term must be equal to the third term. So let's put this to use. So first and third term, the average of first and third term, let's take that. So the first term is log 3. So log 3. Last term is log of 3 to the power x plus 4. So average of this, that means divided by 2, must be equal to log of 3 to the power x minus 2. So this can be rewritten as log of 3 into 3 to the power x plus 4 is equal to, this is equal to 2 times of log 3 to the power x minus 2, which can be written as log of 3 to the power x minus 2 whole square, because this 2 can act as the exponent. So this basically means 3 into 3 to the power x plus 4 must be equal to 3 to the power x minus 2 whole square. Now the question is, how do we find the value of x? So you can assume 3 to the power x. So how to solve this? Assume 3 to the power x to be equal to a, and let us see how it changes. So now the equation becomes 3 times a plus 4 is equal to a minus 2 whole square. So now let's solve a. So this gives us 3a plus 12 is equal to a square plus 4 minus 4a. So this can be written as a square minus 7a minus 8 is equal to 0. So if you'll solve this, a minus 8a plus a minus 8 is equal to 0. So a comes out to be equal to 8. So a comes out to be equal to 8. It means 3 to the power x is equal to 8, which means x log 3 is equal to log 8. So x is equal to log 8 by log 3, which in turn is equal to log 8 to the base 3. Now this is a very good question, but you need to be a bit careful while solving such questions. So let's see. So log 4 to the base a. Here see, neither the numbers nor the bases are same. So how to solve this? So you can simply break each term in fractional form. So the terms basically take this form: log 4 by log 2 into log 8 by log 4 into log 16 by log 8. So if you observe carefully, the terms keep on cancelling diagonally. So this must be cancelled again. So let's suppose the last term. So you see, the terms are what is nth term equal to? Nth term, so first things first, nth term can be written as log 2 to the power n of 2 to the power n plus 1. So this is the situation. So this can also be written as n plus 1 upon n plus 1 upon n, because if you take this n plus 1, it will act as a product. If you take this n out, it will act as a reciprocal. So the overall it will become n plus 1 divided by n log 2 of 2. Okay, so now let's see. So the first term can be written as 2 by 1. Second term can be written as 3 by 2. Third term can be written as 4 by 3. And nth term is of course n plus 1 upon n. So if you see carefully, all these terms actually get cancelled and we are simply left with, see, this 3 cancels, this 3, this 2 cancels, this 2. So this will also get cancelled, but this won't get cancelled. So final answer would be n plus 1. So now it is given to us that n plus 1 is equal to 49. So this means n must be equal to 48. This was first method to solve. We will also see alternative method to solve this. So let's see. Let's see the alternative method to solve this. So the terms when written in fractional form become something like this: log 4 by log 2 into log 8 by log 4 into log 16 by log 8, and so on up till nth term. So nth term would be what? Log of 2 to the power n plus 1 whole divided by log of 2 to the power n. So as you can see that these diagonal terms are bound to cancel. So these terms are definitely going to get cancelled. So you would be left only with log of 2 to the power n plus 1 whole divided by log 2. So this again comes out to be n plus 1 into log 2 by log 2. So this is given to us as 49. So from this approach as well, we get that n is equal to 49 minus 1 equal to 48. So whichever approach you take, the answer has to be same. Now let's move to the next one. So this series is given before us. So series are alternately added and subtracted, minus, plus, minus, plus. So a sequence of minus and plus in alternate places. So how to solve this? Again, you have to make use of this fact that log a to the base b can also be written as log a upon log b. So you have to simply apply this rule here and it will be solved. So let's do that. So let's rewrite the expression. So this expression can be rewritten as 1 upon log 100 by log 2. Similarly, second term can be written as minus 1 of log 100 by log 4, and so on. So the last term can be written as 1 by log 100 whole divided by log 50. So this can be rewritten as log 2 by log 100. Please mind the use of minus and plus. So don't ignore this sign, otherwise you will get the wrong answer. So minus of log 4 by log 100 plus log 5 of log 100, and so on up till the last term is plus. So log 50 of log 100. So you can take log 100 as common in the denominator. So numerator now becomes log 2 minus log 4 plus log 5 minus log 10 plus log 20 As you can see, the sign is plus here. So minus log 25 and then ultimately plus log 50. So now you can apply the rule of product and division in the numerator. So numerator becomes log of 2 into 5. All the plus terms are multiplied and all the subtracted terms are to be divided. So 2 into 5 into 20 into 50 whole divided by 4 into 10 into 25. So 25 into 400,000. So 1000. So this and this entire things get cancelled by log 100. So this comes out to be log 10 upon log 100. So this is 1 by 2 because the base can be assumed to be 10. So 1 by 2 is the answer. So why did I write it as 1 by 2? Because if no base is given, you can assume the default base to be equal to 10. Suppose if log 1000 is given, no base is given, then you have to assume this to be equal to 10. So that is what we did in the last step. So this again same approach just like before. So all these terms are, so this can be written as log 2 to the log 8 divided by log n. This can be written as log 32 divided by log n. This can be written as log 128 divided by log n. Now notice something, this 2, 8, 32 and 128, all these are powers of 2. So what can we do with this? So this can be written as log 2 by log n. So again a very similar question. So let's see how can we solve this. The given expression can be rewritten in form of fraction. That means log a to the base b has to be expressed in the form of log a by log b. So let's do that. The given expression can be rewritten as log 2 by log n. So we are taking term by term. So this term can be rewritten in this manner. Similarly, this term can be written as log n divided by log 8. So 8 can be written as 2 cube. If you have observed 2, 8, 32 and 128, they have been chosen consciously. What's so conscious about them? That all these 4 numbers are powers of 2. So let's make use of that as well. Now third term. So third term can be written as log 32. So 32 is what? 2 to the power 5 divided by log n. Similarly, last term can be written as log n divided by log 128. Now 128 is what? So 128 is 2 to the power 7. So if you see carefully, these log n terms, they cancel each other out. So what are we left with? We are left with log 2 into 1 by, this 3 can be taken outside and multiplied. Similarly, this 5 can be taken out. Similarly, this 7 can also be taken out. Now this log 2 terms cancel each other out and we are simply left with 5 divided by 3 into 7, which is equal to 5 divided by 21. So this is the final answer, 5 divided by 21. So let's move further. So log AB to the base A is equal to X. Then what is log AB to the base B equal to? So let's see. Let's concentrate on what is given to us. So log AB divided by log A is given to us as equal to X. So this can be written as product rule. Log AB can be written as log A plus log B divided by log A is given to us as equal to X. So this can be written as 1 plus log b to the base a is equal to x. So from here we can conclude that log b to the base a is equal to x minus 1. But this is not what we are asked to find. We are asked to find something else. So let's see what we are actually asked to find. So we are actually asked to find this. So this can be written as log a plus log b whole divided by log b. So this is log a to the base b plus 1. So if you take reciprocal of it, this becomes 1 by log b to the base a plus 1. So we know that this is equal to x minus 1. So this is what we are supposed to find. So what we are supposed to find has the value of 1 by x minus 1 plus 1. Let's see what this comes out to be if you take x minus 1 as common. So x minus 1 plus, so this will be 1 plus x minus 1. So this comes out to be x divided by x minus 1. So D is the answer. So now let's move further. So similarly, you have to break it in the form of log a by log b. So let's rewrite this. So this can be written as log ab upon log abc plus log bc upon log abc plus log ac upon log abc. So if you take log abc as common in all the three denominators, you will get log ab plus log bc plus log ac. So this can further be written as product rule. Log a plus log b plus log c can be written as log abc. So if you multiply, this will become log of a square b square c square whole divided by log abc. So this can further be written as log abc whole square divided by log abc. So this is what equal to 2. This 2 comes out and log abc cancels. Okay, now this one. So we'll have to solve this equation step by step, removing one log at a time, moving this way, because x is situated on the rightmost side, so we'll have to move from the other end towards x. So from this way, so if you remove one log at a time, so it means 9 raised to the power half is equal to 3 log 2 1 plus log 3 into 1 plus 2 log 2x. So you are removing one log at a time. So this 9 raised to the power half must be equal to the remaining portion. So it means 9 raised to the power half means square root of 9. So 3 is equal to this much, is equal to 3 log 2 1 plus log 3 of 1 plus 2 log 2 of x. So this 3 and this 3 cancels, becomes 1. So now 2 to the power 1. So 2 to the power 1 must be equal to 1 plus log of 3. So 1 plus 2 log 2x. Okay. So if this 1 is taken this side, it means 2 minus 1. That means 1 is equal to log 3 of 1 plus 2 log x to the base 2. So this can further be rewritten as 3 to the power 1 is equal to 1 plus 2 log 2x. So this means 3 minus 1, 2 is equal to 2 log x to the base 2. So this 2 and this 2 gets cancelled. It means 2 to the power 1 is equal to x, or in other words x is equal to 2. So you have to remove one log at a time, and you have to move from this way towards the right. Why? Because this x is situated in the rightmost side, so you have to keep removing log from the leftmost hand. So now let's move. So let's see, this is a very good question. So it is given to us that log x to the base 2 plus log x to the base 4. Now 4 can be written as 2 square. Now this is equal to, now 0.25 can be written as 1 by 4. Now you see 1 by 4 can be written as 2 to the power minus 2. So this means what is given to us is actually log x to the base 2 plus this will come out as reciprocal, plus half of log x to the base 2 is actually equal to, now this minus 2 will also come out as reciprocal, minus half of log 2 root 6. Now you see, so this can be written as log 2 can be taken as common. So x, now this half will become square root. So this thing is equal to log 2. So root 6 to the power minus half. So it indicates that x to the power 1.5 is equal to 6 to the power minus 0.5. So now what? How do we find the value of x? So this is again a very good question. Let's see how to solve this. As you can see that the bases are all different, but still if you can realize that 2 and 4 both are powers of 2, that means something has to do with base 2. So let's transform this given equation. The given equation can be written as log x to the base 2 plus this 4 can be written as 2 square plus log x to the base 2 square is given to us as equal to log of, now 0.25 can be written as 1 by 4. Root 6 can be written as 6 to the power half. So this can further be rewritten as log x to the base 2 plus this exponent from the base when taken outside becomes reciprocal, plus half of log x to the base 2 is equal to log of, now 4 can be written as 2 square. So 1 by 2 square can be written as 2 to the power minus 2. 6 whole to the power half. So this when taken outside will become half to be multiplied minus 2 to be taken as reciprocal, and then log 6 to the base 2. So this means log x to the base 2 plus half of log x to the base 2 is equal to minus 1 by 4 log 6 to the base 2. Now this means if you take log 2 as common and apply the product rule, this becomes x into root x, because this half means square root, is equal to log of 2 6 raised to the power minus 1 by 4. So from here it is clear that x to the power 1 plus half is equal to 6 to the power minus 1 by 4. So it means x to the power 3 by 2 is equal to 6 to the power minus 1 by 4. So from here it is clear that x is equal to 6 to the power minus 1 by 4 whole raised to 2 by 3. So this is 6 to the power minus 1 by 6. Now this is a very good one. So what is given to us? It is given to us that log x of 9 by 32 is equal to minus 1 by 8. So one side log is given, the other side it is not given. So let's bring log on both the sides. So this can be written as log x to the base x, because this effectively is equal to 1. So this now transforms into log 9 by 32 to the base x is equal to log x raised to power minus 1 by 8. So it is very clear from here that x raised to power minus 1 by 8 is equal to 9 by 32. So if you take reciprocal, 1 by x to the power 1 by 8 is equal to 32 by 9. So from here it is clear that x to the power 1 by 8 is equal to 9 by 32. So x is equal to 9 by 32 whole to the power 8. Now log 360 is equal to what? So log of 360 can be written as 30, or if you can break it into prime factorize, let's prime factorize. So this will be 2 cube into 3 square. So 8 9s are 72 into 5. So this is what 360 is equal to. So this can be written as 3 log 2 plus 2 log 3 plus log 5, because this 3 will go outside and become, it will be multiplied as it is. So let's see this one. So log 2 to the base 10 is given to us, and based on this we have to find the value of log 1600 to the base 10. So somehow the idea behind such question is to express the second number in terms of the first one. So can 1600 be expressed as powers of 2? Of course not, but 16 can be. 1600 is not a power of 2, but 16 is. If only you realize this, then see how things would take a turn. So 1600 can be written as 16 into 100. So this will be log 16 to the base 10 plus log 100 to the base 10. So 16 can be written as 2 to the power 4. So 4 will come outside. So log 2 to the base 10 into 4 plus log 100 to the base 10 is equal to 2. So this comes out to be 4 into. So the value for log 2 to the base 10 is given to us. Okay, and then plus 2. So this comes out to be 1.204 plus 2. So this is equal to 3.204. So this is the correct answer. Now let's move further. Okay, again a good one. So log 2 to the base 10 is given, log 3 to the base 10 is given. That means if no base is mentioned, you'll have to assume it to be equal to 10. And based on this, you'll have to find the value of this. So 512 is very evidently equal to 2 to the power 9. So let's for the time being concentrate only on what we have to find out. So we have to find out log 512 to the base 5. Now log 5 value is not mentioned here. We only know the value of log 2 and log 3. So somehow we will have to rewrite this term to incorporate log 2 and log 3. So let's see how that can be done. So this can be written as log 512 by log 5, both to the base 10, common base. So this is 9 times log 2, because 512 is equal to 2 to the power 9. Now here comes the trick. Log 5 can be written as log of 10 by 2, because 5 is nothing but 10 by 2. Why did we do so? Because we only know the values of log 2 and log 3. So we can't use any other number. So to express 5, we used 10 by 2. So this can be written as 9 times of log 2 whole divided by log 10 minus log 2. Okay, now we simply substitute this value. So this is equal to 9 times of log 2 is already known to us. It is 0.3010 whole divided by log 10. The base is 10. So log 10 to the base 10 is actually equal to 1. So 1 minus, again log 2. Log 2 is 0.3010. So this is 9 times. So 2.709 whole divided by 0.699. So this comes to be very near to 3.876. So this is the correct answer. So now let's move further. Again, similar situation, log 2 to the base 10 is given, log 7 to the base 10 is given, but we are expected to find log 2.8. So first understand how can we express 2.8. So 2.8 can be written as 28 by 10, which can be written as 2 square. That means 4 into 7 by 10. Why did we take this approach? Because we know the value of log 2. We also know the value of log 7. We also know the value of log 10. So this is how we should write 2.8. So now we are being asked to calculate the value of this, which can be rewritten as this. So we express this further as 2 log 2 plus log 7 minus log 10. So 2 into 0.301 plus 0.8451 minus, what is log 10? Log 10 is 1. So this is 0.602 plus 0.8451 minus 1. So this comes out to be equal to, so if you'll solve this carefully, this comes out to be 0.4471. So now let's move further. So again, a very good question. So log 27 to the base 12 is equal to A, log 16 to the base 9 is equal to B, and based on these two equations, we are supposed to find the value of log 108 to the base 8. So let's see, first of all, what information is actually conveyed to us. So it is being conveyed to us that log 27 by log 12 is equal to A. So this actually means 27 can be written as 3 cube. So 3 log 3. 12 can be written as 2 square of log 2 square into 3. So this is actually given to us as equal to A. So it is told to us that 3 log 3 whole divided by 2 log 2. Why 2 log 2? Because it is here 2 square. So if this 2 will come out, it will act as multiplication factor. So 2 log 2 plus log 3 is equal to A. So this is given to us. Now, based on second fact, that log 16. So log 16 can be written as log 2 to the power 4 divided by log 9. 9 can be written as 3 square. So this is given to us as equal to B. So from here you can see that 4 by 2. That means 2 log 2 by log 3 is given to us as equal to b. So now using these two facts, this is fact number 1 and this is fact number 2. Using these two facts, now we have to solve the value of 108 to the base 8. So let's do that. Let's first understand what is log 108 to the base 8 actually equal to. So this is equal to log of 2 square into 3 cube divided by log of 2 cube. So if you arrange properly, this is actually equal to 2 log 2 plus 3 log 3 divided by 3 log 2. So now we have to find the value of this expression in terms of a and b. So if you expand this further, this comes out to be equal to 2 by 3, log 2 and log 2 cancels. So 2 by 3 plus 3 by 3 is also cancelled, plus log 3 by log 2. So from here log 3 by log 2 will be equal to 2 by b. So is equal to 2 by 3 plus 2 by b. So if you'll solve this, this comes out to be equal to 2b plus 6. So if you'll take 2 common, so 2 into b plus 3 whole divided by 3b. So 2 into b plus 3 whole divided by 3b is the correct answer. This is the correct answer. So now let's move further. P cube is equal to q to the power 4 is equal to r to the power 5 is equal to s to the power 6. So then the value of log s p q r is equal to what? So let's see. The easiest way to solve this is to express p, q and r in powers of s. So what is meant by this? We know that p cube is equal to s to the power 6. So if you take the cube root, so it means p is equal to s to the power 6 by 3 is equal to s square. Similarly, q to the power 4 is equal to s to the power 6. It means q can be written as s to the power 6 by 4, which is equal to s to the power 1.5. So by now we have understood two things. First is p is equal to s square. Now we know that q can be written as s to the power 1.5 or else 3 by 2. Similarly, r to the power 5 is equal to s to the power 6. So r can be written as s to the power 6 by 5. So r can be written as s to the power 6 by 5. Now see what we are supposed to find. We are supposed to find this. We are supposed to find log p q r to the base s. So let's do that. So log of p q r. Now what is p into q into r equal to? In terms of s, it will be equal to s square into s to the power 3 by 2 into s to the power 6 by 5. So let's see what is PQR in terms of s equal to this, that is equal to s to the power 2 plus 3 by 2 plus 6 by 5. So this comes out to be s to the power, you can take 10 as common. So 20 plus 15 plus 12. So this comes out to be s to the power 47 by 10. So now log PQR to the base s can be written as log s to the power 47 by 10 to the base s, which is nothing but 47 by 10 log s to the base s. So log s to the base s is what? It is equal to 1. So this comes out to be 47 by 10. So now let's move further. So this is a very good one. Log y to the base x plus log x square to the base y is equal to 3, and based on this information we are being asked to calculate the value of log y cube to the base x. See, if you will see something, if you observe something, if you understand something, that log a to the base b and log b to the base a are reciprocals. They are reciprocals. So same is going on here. You can see log y to the base x, and here you can see the use of log x to the base y. So what to do? You can simply assume log y to the base x to be equal to a. So the information given to us transforms. So how does this transforms? So it becomes log y to the power x plus, this can be rewritten as 1 by log y of x square. This is given to us as 3. So now see, this can further be written as log of y to the base x plus, if this 2 is taken out, it becomes reciprocal, plus 1 divided by half of log y to the base x. So this is given to us as equal to 3. So now if you assume this to be equal to a, so what is actually given to us is a plus 2 by a is equal to 3. So this is what is given to us. Okay, so if you see carefully, a is equal to 2 satisfies this equation. A is equal to 2 satisfies this equation. So it means a is equal to 2. So what is a? We have assumed this to be equal to a. So therefore we are trying to say that log of y to the base x is equal to 2. What are we trying to find? We are trying to find log y cube to the base x. So this is actually equal to 3 times of log y to the base of x. Now let's see this one. This is a very good question. In fact, a very common one. So you need to be very careful, on this one at least. So let's see. So before we get down to solving this, let me remind you something. So log a to the base b is actually the reciprocal of log b to the base a, as we saw in one of the rules. So the same has been done here. If you see the terms, this term is log y to the base x, while the second term is log x to the base y. So they are using reciprocal bases. So let's see. So first of all, what is given to us? It is given to us that log y to the base x plus, if you take this 2 outside, it can be simply multiplied 2 times of log x to the base y is equal to 3. This is given to us. Now assume this to be equal to a. So I can say that a plus 2 by a is equal to 3, because log x to the power base y is the reciprocal of log y to the base x. So if this is a, this is actually 1 by a. Now if you see carefully, a is equal to 1 satisfies this equation. A is equal to 1 satisfies this equation. So what does this mean? It means log y to the base x is equal to 1. Log x to the base y is equal to 1. So it becomes very simple. So what does this mean? It means that x to the power 1 is equal to y, or in fact x is equal to y. Now what are we supposed to find? We are supposed to find log x y cube. Now x is equal to y, so I can write 3 times of log x to the base x is equal to 3, because log x to the base x will be equal to 1. Now let's move further. So now this question again is based on the same concept of reciprocality. So if you can observe here the terms, log x to the base 3 and log 3 to the base x, they are simply reciprocals of each other. So if you assume log x to the base 3 to be equal to a, the given equation then changes to a plus 1 by a is equal to 17 upon 4. Okay, so if you are in practice, you know, these questions such as these are actually gifts, because 4 plus 1 by 4 is equal to 17 by 4. If you are in practice, you will easily realize this. If not, then you'll have to actually solve this. If you were in practice, you could have immediately said that, okay, a must be equal to 4. But not to worry, it might not come easily to each one of you. So suppose that it didn't occur to you that a is equal to 4, then you could have solved this as well. So how to solve that? Let's see. So a square plus 1 is equal to 17 upon 4. So from here you can see that 4a square, minus 17a plus 4 is equal to 0. From here you can see that 4a square minus 16a minus a plus 4 is equal to 0. From here you can take 4a as common, a minus 4. From here you can take minus 1 as common, a minus 4 is equal to 0. From here you can see that a is equal to either 4 or 1 by 4. Okay, a is equal to either 4 or 1 by 4, because these are reciprocals after all. So if a satisfies the equation, 1 by a will also satisfy. That's why you can see that both the answers that you are getting are also in fact reciprocals. So now you see, assuming a to be equal to 4, we can say that log x to the base 3 is equal to either 4 or 1 by 4. So based on this, x is equal to either 3 to the power 4 or 3 to the power 1 by 4. Both these answers are acceptable, are roots. Now this one, 2 to the power 6x plus 2 to the power 3x plus 2 minus 21 is equal to 0. The real roots of the equation. That means what value of x when substituted here satisfy this equation. So that value is known as the root. So let's observe something. 2 to the power 3x, there is certain relation between 2 to the power 3x and 2 to the power 6x. Questions such as these carry ample amount of hint with them. So there is a very clear-cut hint. The terms used are very evidently carrying a hint. 2 to the power 6x and 2 to the power 3x. How are they related? So 2 to the power 3x whole squared is equal to 2 to the power 6x. So what to do as soon as you observe this? You can assume 2 to the power 3x to be equal to a. Okay, so now you see what this equation can be rephrased as. This equation can be rephrased as a square plus 4a, because 2 to the power 3x plus 2 can be written as this 2 square will become 4 times of 2 to the power 3x. So that's why a square plus 4a minus 21 is equal to 0. So now you can find the roots of this quadratic equation. A square plus 7a minus 3a minus 21 is equal to 0. So if you take a as common, a plus 7, here you take minus 3 as common, a plus 7 is equal to 0. From here you can see that a minus 3 into a plus 7 is equal to 0. So it means a is equal to either 3 or minus 7. So it means 2 to the power 3x is equal to either 3 or equal to minus 7. Now understand something. A to the power x can never be negative. So the only possibility is 2 to the power 3x is equal to 3. So 2 to the power, now we have to find the value of x as well. 2 to the power 3x is equal to 3. It means taking log both sides. 3x log 2 is equal to log 3. So it can be written that 3x is equal to log 3 to the base 2. If you take log 2 here and divide, so it assumes the form of the base itself. So from here x is equal to log 3 to the base 2 whole divided by 3. So option A is the correct answer. So now let's move further. So this is a very good one. Again, you have to observe, you have to be very observant while solving questions of algebra, because questions of algebra, you know, if you have not solved such a question before, or if you fail to observe something, it will become virtually impossible for you to crack that question. But if you know it beforehand, you know, because as I already told you that these questions are based on certain patterns, certain tricks, certain substitutions, so you have to be very observant. So if only you could observe that the numbers that are being used are 5.55 and 0.555. So how are these two numbers related? 5.55 and 0.555, how are they related? This one divided by 10 becomes equal to this. Okay, so now let's rewrite this. So it is given to us that 5.55 whole to the power x is equal to 5.55 divided by 10 to the power y is equal to 1000, which is equal to what? 10 cube. So now let's see, let's take log at both these sides. So I can say that x log 5.55 is equal to y log, or let this be as it is, log 0.555 is equal to 3, because if you take log here, it will come out to be 3 log of 1000. Now 1 by x. So concentrate on these two terms. So 1 upon x can be written as log 5.55 by 3. 1 by y can be written as log 0.555 by 3. So if you take, so this is actually equal to 1 by x minus 1 by y, and we are supposed to find the value of these very terms. So now you take 3 as common. So now students, let's see this question. This is a very, very good question, and this has been asked at least a couple of times in previous 2 to 3 seasons. So please be very, very careful. So let's see how to solve this one. So please observe something. 5.55 and 0.555 are deliberate choices. They have been chosen deliberately. They are not random numbers. So 5.55 and 0.555. So how are these two numbers related? The first number when divided by 10 becomes equal to the second one. So we'll have to somehow make use of this fact as well while solving this question. So now let's move further. So what is given to us? It is told to us that 5.55 whole to the power x is equal to 0.55 can be written as 5.55 whole divided by 10 to the power y is equal to 10 cube. This is given to us. Now take log. Take log of all these three terms. So it would mean that x log of 5.55 is equal to y times of log 5.55 minus log 10, because it is of the format a by b, minus log 10 is equal to 3, because log of 10 cube is 3. So look carefully, it means x log of 5.55 is equal to y times of log 5.55 minus 1, because log 10 to the base 10 is equal to 1, is equal to 3. Now see, what are we supposed to find? We are supposed to find 1 by x minus 1 by y. So 1 by x is equal to 3 divided by log 5.55. Similarly, 1 by y can be written as log 5.55 minus 1 upon 3. So 1 by x can be written as log of 5.55 whole divided by 3, and 1 by y can be written as log of 5.55 minus 1 by 3. Now solving 1 by x minus 1 by y. 1 by x minus 1 by y is equal to log of 5.55 by 3 minus log 5.55 minus 1 whole by 3. So if you'll solve this cancels out. So 1 by 3 is the answer. This is the correct answer. So now let's move further. So let's see the next one. So this is a very good question again. So although all the questions are good, but this is one of the most difficult questions from this entire lecture. So I insist that you first try this on your own. Pause this video, read it carefully, give it a try, only then you look at the solution. So I hope you must have tried. So now let's solve this together. So log, what is given to us? First of all, let's understand that what is given to us. So it is given to us that log 81 to the base 12 is equal to p. So if you break this further, this means that log 81 by log 12 is given to us as equal to p. So log 81 is actually log 3 to the power 4. Similarly, log 12 can be written as 2 square into 3, log of 2 square into 3. So if you simplify this further, this comes out to be 4 log 3 divided by 2 log 2 plus log 3. So this is given to us as p. So let's be very clear, what do we know? We know that 4 times of log 3 whole divided by 2 times of log 2 plus log 3 is given to us as equal to p. Look at what we are supposed to find. We are supposed to find this expression. So here is a hint. Here is a very big hint. In fact, it hints towards componendo dividendo. So what do we mean by componendo dividendo? If it is given that a by b is equal to c by d, then we can safely conclude that a minus b by a plus b is equal to c minus d by c plus d. We have to do something very similar here. So now from here we can say that 4 by p is equal to 2 times of log 2 plus log 3 whole divided by log 3, 4 by p. So this can further be written as 2 times log 2 by log 3 plus 1. So if you see carefully, so up till now we have been able to deduct that 4 upon p is equal to 2 log 2 plus log 3 upon log 3. Now apply componendo dividendo. 4 minus p by 4 plus p will be equal to, here this is numerator, this is denominator. So 2 log 2 plus log 3 minus log 3 whole divided by 2 log 2 plus log 3 plus log 3. So if you will solve this carefully, this log 3 and this log 3 will get cancelled. 2 times of log 2 whole divided by, you can take 2 common, log 2 plus log 3. So this indicates that 4 minus p into 4 plus p is actually, this 2 and this 2 also gets cancelled, is equal to log 2 divided by, now log 2 plus log 3 can be written as log 2 into 3. So log 2 into 3 means log 6. But see, we have to find the value of this expression 3 times of componendo dividendo. 3 times. So let's multiply this by 3. So it indicates that thrice of 4 minus p divided by 4 plus p is equal to thrice of this. So 3 times of log 2 to the base 6, because this 6 when removed from denominator will become its base. So this can be written as log of 2 cubed to the base 6 is equal to log 8 to the base 6. So let's see, log 8 to the base 6, this will be the correct answer. Now let's move further. Again a very good one. The value of this expression is equal to, now you see, root 5 can be written as what? It can be written as 5 to the power half. Similarly, 0.008 can be written as 1 by, or in fact 8 by 1000, which you will cancel, you will get 1 by 125. Similarly, root 3 can be written as 3 to the power half. 81 can be written as 3 to the power 4 minus 7. Now you can apply the rule of exponents. So this is actually equal to log of 5 to the power half 5 cube plus log of 3 to the power 4, base is 3 to the power half minus 7. So this half can come out and get multiplied as it is. This 3 will come out and become the reciprocal 1 by 3 log 5, base is also 5, plus this 4 will come out and get multiplied. This half will come out as reciprocal, so it will get multiplied. Half will become 2, so 4 into 2 of log 3 to the base 3 minus 7. This is what we are asked to calculate. So this is 1 by 6 plus 8 minus 7 is equal to 1 plus 1 by 6 is equal to 7 by 6. So 7 by 6 is the correct answer. So let's move further. So dear students, here is the next question before us. So this again is a very good and in fact a tricky one. So let's see. So what is given to us? It is given to us that log to the base 10 of x minus log to the base 10 of cube root of x is equal to 6 times of log 10 to the base x. So this is given. Now you see, on one hand, this side both the bases are same, both the bases are 10, but here it is not the case. So what to do? So let's see. This can be rewritten as log x to the base 10 minus cube root of x can be written as x to the power 1 by 3. So this can be written x to the power 1 by 3. So this is given to us as log of x 6 times this much. So now see, you can apply the division rule here. So how? I can write this as x divided by x to the power 1 by 3 log to the base 10. So this is given to us as 6 times of log 10 to the base x. So this means log x to the power 2 by 3 to the base 10 is given to us as this much. But still the bases on both sides are different. So let's see how can we resolve this. So 2 by 3 can be written here. So 2 by 3 times of log x to the base 10 is equal to 6 times its reciprocal. So 6 times its reciprocal. So 6 divided by, you can take the reciprocal, log x to the base 10. Okay, so let's suppose log x to the base 10 to be equal to a. So let's assume log x to the base 10 to be equal to a. So what do we know so far? We know that 2 by 3a is equal to 6 by a. So we know that a square is equal to 9. From here we know that a is equal to 3. So if a is equal to 3, what have we just assumed? We have assumed log x to the power to the base 10 to be equal to a, which came out to be equal to 3. So from here it is very evident that x is equal to 10 cube is equal to 1000. In such a situation, I would insist that you try to substitute the options, because that comes very easy. If you try to substitute the options back, you can easily eliminate the wrong ones and actually filter in the correct one. Now let's see this one. So let's see what this question is all about. So let x and y be positive real numbers such that log x plus y to the base 5 plus log x minus y to the base 5 is equal to 3, and log y to the base 2 minus log x to the base 2 is given as 1 minus log 3 to the base 2. Okay, so this side both the bases are same. Here also both the bases are same. So we'll make use of that. So first concentrate on this fact, or this equation that is given to us, this one, only this portion. So this can be rewritten as log x plus y to the base 5 plus log is equal to 3. So what can we write this as? Base is same, so log 5 x plus y into x minus y, so this becomes x square minus y square. So this is given to us as 3. Why? Because it is the product rule. Log a plus log b can be written as log ab. So here a is x plus y, b is x minus y, so ab becomes x square minus y square. So from here it is very evident that x square minus y square is equal to 5 cube is equal to 125. So first information have been decoded, and this is what we got, that x square minus y square is equal to 125. This is the first piece of information that we got. Now let's try to solve this second equation and let's see what can we figure out. So this can be written as log 2, both the bases are same, so we'll apply the division rule or subtraction rule. So this can be written as log y by x to the base 2 is equal to, now 1 can be rewritten as log 2 to the base 2 minus of log 3 to the base 2. So from here you can see that log y by x to the base 2 is equal to, again you can do the same here. So from here y by x is equal to 2 by 3. So we have two pieces of information. So let's solve this. Let's assume y to be equal to 2k and x to be equal to 3k. So x square, that means 9k square minus y square. Y square means 2k whole square, that means 4k square is equal to 125. So from here you can see that k square is equal to 5k square is equal to 125. So from here it is very evident that k is equal to 5 plus minus 5. So we'll assume the positive value here because we are dealing with logarithm. So a, or rather x was equal to 3k, which is now equal to 15, and y was equal to 2k, which is now equal to 10 because k has come out to be 5. Therefore x into y, the product was 150, 15 into 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. 10. Now again, a very good question, almost along this same. So we'll do this step by step. So if let's first solve this, only this portion. So 5 plus log a to the base 3 can be written as 2 cube, exponent rule, 2 cube. So this is equal to 8. So from here you can say that log a to the base 3 is equal to 8 minus 5 is equal to 3. So from here you can see that a is equal to 3 to the power 3 is equal to 27. So a has been solved by using first equation. So a comes out to be equal to 27. So now let's use the second equation and see what it comes out to be. Similarly, 4a plus 12 plus log b to the base 2 must be equal to 5 cube. That means it must be equal to 125. Now a has already come out to be 27. So 4a is what? 108. So 108 plus 12 plus log b to the base 2 must be equal to 125. So 108 plus 12 is what? 120. So from here it is very evident that log b to the base 2 is equal to what? 5. So from here b comes out to be 2 to the power 5 or else 32. So a already found out as 27, b is equal to 32. Now what are we asked to find? A plus b. Therefore a plus b is equal to 27 plus 32. So comes out to be 59. So let's move to the next one. So now let us see how to solve this. This is a very good one. So let's see. So a Pythagorean triplet has been given. A square plus b square is equal to c square. So you know, numbers or real numbers such as these are known as triplets, Pythagorean triplets, such that a square plus b square is equal to c square. Anyways, so now based on this relation we are being asked to find the value of this expression. So let's see what are we being asked to find. So 1 by log, so this can be rewritten as, so if you write this in fractional form, this can be rewritten as log of c plus a divided by log b plus log of c minus a divided by log b. So if you take log b common, then what do we get? We get that log c plus a plus log of c minus a. Now you can apply the product rule. Log a plus log b is equal to log a into b. So this can be written as log of c square minus a square by log b. Now you see c square, from this relation you can say that c square minus a square is equal to b square. So this comes out to be log b square by log b. So this is 2 log b by log b. So log b and log b cancels, we are left with 2. So 2 is the answer, 2 is the correct answer. So now let's move to next one. So the value of x satisfying this equation is, okay, this is a good one. So let's see. Here log is involved, but this side no log is involved. So what to do? Let's see what can be done. So let's rewrite this first. 2 to the power x plus x minus 41 is equal to x minus x log 10 to the base 5. Now there is a problem. This side there is base 10 here. Up till here it is correct, but there is no base 10 here. Then what to do? We can introduce a base 10. How? Now this can be rewritten as log 10 2 to the power x plus x minus 41. To make it homogeneous, we will introduce log 10. How? Because we know that log 10 to the base 10 is equal to 1. So there is no difference. Even if I write this, the equation is maintained. So minus, now this x can act as component. exponent. So this can be written as log 5 to the power x to the base 10. Okay. So now let's rearrange these terms. So the terms are now taking shape. So this can be written as log to the base 10, 10 to the power x minus log 10, 5 to the power base x. So if you rewrite this further, it can be written as log to the base 10 of 2 to the power x plus x minus 41 is equal to, you can take log 10 as common, 10 to the power x divided by 5 to the power x, which is equal to log of 2 to the power x to the base 10. So now you compare these two terms. So if you compare these two terms, it becomes very evident that 2 to the power x plus x minus 41 must be equal to 2 to the power x, which clearly indicate that x minus 41 is equal to 0, which means that x must be equal to 41. Okay, now let's move to next one. So this is a very common pattern of questions. So I'll tell you how these type of questions are to be solved. So log 2 is given to us and we are supposed to find the number of digits in of the format a to the power x. Then we simply take the logarithm. We first find the characteristic and add 1 to it. So I'll tell you how this exactly is done. So now we have to find the number of digits in this one, 4 to the power 50. So what do? You first take log of the number that is given to us. So this can be rewritten as 50 times log 4, but we don't have the value for log 4. Then what do? We write 50 times log of 2 square. Now this 2 comes out. So this becomes 100 times log 2. So 100 into log 2, the value of log 2 is given to us as 0.30103. So this becomes 30.103. So first you will have to do this and then add 1 to the integral part. What is the integral part? That means it is very clear that the answer is more than 30 because it has exceeded 30. So therefore, first you have to find the value of log, and after you have done that, you discard the decimal part, take only the integral part and then add 1 to it. Therefore, number of digits is equal to, discard this decimal part. Decimal part is 0.103. Take only the integral part, 30, and then add 1 to it. So the number of digits will be equal to 31. Let's take another example. So log 2 is given to us, log 3 is also given to us, and we have to find the number of digits in 648 to the power 5. So 648 to the power 5. So let's see. So first we have to take the log of 648 to the power 5. So this is actually equal to 5 times of log 648. Now 648 can be further written as, if you prime factorize this, so this is actually 2 to the power 3 into 3 to the power 4. So this can further be written as 5 times of, now log a into b can be written as log a plus log b, and this exponent can be taken out. So this ultimately becomes 3 log 2 plus 4 log 3. So this is 5 into 3 times of 0.30103 plus 4 times of log 3 is given to us as 0.4771. So if you solve, this comes out to be equal to 14.05. So now step 2 is that this is not the final answer. Final answer is you discard the decimal part and then add 1 to the characteristic. So final answer or total number of digits, you discard the decimal part. So if you discard the decimal part, you are left with only 14 and then add 1 to it. 14 plus 1 equal to 15. So 15 is the final answer. So now let's take one final question from this topic. So log 2 is given and we have to find the number of digits in 2 raised to the power 128. So what do? We take log. So log of 2 to the power 128. Now we already have the value for log 2, so we need not do much here. So this can be written as 128 into log 2. We already have the value for log 2. So 128 into 0.30103. So what does this comes out to? So this comes out to be 38 point something. So 38.3 something. So now this is not the final answer. The final answer can be reached about in step 2. What is step 2? You discard the decimal part and add 1 to the remaining portion to the integral part. So number of digits will be equal to, you discard the decimal, 38 plus 1. So 39 will be the final answer. So this is the final answer. Okay, so that is all from this topic, logarithm. So I would insist that you watch this video at least twice, because many tips and tricks may not have come easier for you on the first go. So I would insist that you can try to solve it again on your own. Okay, so that it is actually highlighted to you that which tricks you actually understood, which tricks you could not pick up. So that will become very evident before you. So please give it a try again. Watch this video again. Try to do all these questions on your own at least once.